Once again. Welcome once again to the Machine Learning Basic Bootcamp program. So today's going to be like the wrap-up class for the machine learning track. And we'll be going through the Capstone project for the track. And I'll be showing you what typical machine learning projects should look like, right from the data gathering, data collection, exploratory data analysis, a wrap-up of all that we've been doing in class. So I'm going to be going through that shortly, very quickly. Okay, so on the LMS, we have like a project description. So that's where I'm trying to get to. Let me just navigate to that page. Okay, so I'm trying to open the page. So the project was posted on the 16th. Today is 19th, on the 16th, I guess. Or okay, 17. Okay, this is the project. So on the 16th, we have the project posted, and what we're supposed to do, it says that throughout the bootcamp, you would work on a series of capstone projects that will integrate the skills and knowledge you acquire in each course. So we are supposed to do like two basic exercises, which have been linked on the LMS. So ensure you try your hands on those exercises aside the in-class exercises. All right. So today's projects will be looking at how to approach our projects for people that will be doing the machine learning projects. Okay, so the instruction is, I'm going to just go right into the instructions because we have a lot to do. Okay, so you doing a machine learning project is you're going to have to use the data analysis. You're going to use the data analysis skills as well as data manipulation skills plus machine learning, model building, model development skills. So you're going to put all of those skills together into the project. So the task you have before you is to build and evaluate a machine learning model on a given data set. So there are different places, different ways to do your data gathering when you're faced with a machine learning task or project. Usually, if you have an organization that you work with, you can gather data from your database management team, and then they provide you the necessary data for the task that you want to work with. Or if it's a new kind of problem, you might have to source for data yourself. And one of the ways to do that, one of the ways to do that is through you can do focus groups, discussion, do survey, do some sort of data scraping, web scraping. And also we have some other websites where you could get data from, like real life data sets that some persons have already gathered and then they provided for external use. So you just make sure you cite them when you're using their data. Okay, so we have different data sources here. We have the data.gov, Kaggle dataset search based on the kind of problem that you want to solve. So for this demo, I'm going to be using Kaggle. I'm going to be using a data set from Kaggle. All right. So after you gather your data, you download your data. Okay, so you'll be making use of different tools like Python, your Jupyter Notebook, Panda, Seaborn, or Matplotlib, Scikit-learn. Then if you want to publish your work, you can use your Streamlit to, for people, for external interaction, you can use Streamlit to interact with your data, which allow people from external users to interact with your model. Okay, so having done all of this, you'll be making a submission of your notebook that you worked with, and then, or a GitHub repository. Probably you've loaded up your project on a GitHub repo. You can share the link and send it in an email to community@datagenzyafrica.com or datagenzyafrica@gmail.com. So to enable us to collate everything together, I would share a form. So instead of just sending that as an email, you could just fill that form and then, or you upload your project to that form. Okay, so I'll be doing that. We'll be doing that as well before Monday. You'll be getting a message to where to submit your project. Okay, so everything you're going to be filling a 3-page slide deck. So we'll be having a presentation on Wednesday. We'll be communicating to you via emails, but your project will be submitted before, or not before the end of Tuesday, and then we'll be having a demo for as many people that submit their projects. We'll be having like a 3 minutes, just share with us what you did, the steps, and very briefly, let me quickly, so that you can have a feel of presenting your ideas beyond just working on your project. You have a feel of presenting your ideas to a general audience. Okay, I'll just quickly go to the link to the slide deck, so that let me just click on that. For based on the projects that you'd want to that you'll be doing, based on the project that you want to choose. So we are in the machine learning class, so you can go straight to the slide for your machine learning projects. Okay, you can delete all other slides that are not relevant. So we're still going to merge all the slides together. So for your machine learning project, just have a brief about you, your name, where you're working or schooling, and just a tree. It's going to be a 3-slide deck. So, and then you have your project title, where you downloaded the project from, how many rows and columns you explored, the file size and all of that, the top predictor, what are the top predictors in your data set. And then you can also mention the model you used and then the results of your model. Okay. And then you can also mention some data exploration, some insights you gathered from your data. So you can do all of that and explain to us what were the key insights from your data. And then if there is any link to see what you've done, you can also share with us as well. So the presentation is just going to be a 3-slide, and you share it. You also send it to that, upload it on that form as well. Okay, do we have any questions regarding the projects before we go into the demo? Any questions? Okay, so let us get started with the demo, the project walkthrough. Okay, so assuming I want to take on this task, the ML project task, and I have to, the first thing I need to do is to get my data, the data I want to work on. So I'm going to go back here because I'm working on Kaggle. So I'm just going to click on the Kaggle data set. Let me open it in a new tab so as to have a feel of, on it another piece. So on Kaggle, you have different types of data. All right, you have data sets regarding different types of data sets. You can see them here: gym customer features and churn, Bella Beat case studies, different ones. So I want to work on, I'm going to choose a niche. I want to work on a data set that has to do with cars, maybe car prices. So I'm going to just search for car prices or something. Let's see. Okay, so we have lots of data sets. We have the car price prediction challenge. This one was a competition. You have the car price prediction data set. So you have a lot of data set on car prices. But the one I eventually downloaded was the one that has to do with UK used prices, UK used cars. So let me just go there to search for it further. Okay. And you can do so with this project. You can analyze You can do data analysis on the car. You can do, lots of things with the car. So this was one data set I used. So let me just go to the notebook so that I can get the link to the data sets. So there is this 100,000 UK used car data set. So this somebody collated scraped data of all used car listing, about 100,000 of them, and separated them into different files depending on the car manufacturer. And then the purpose of him doing that is that he wanted to make a tool to predict how much his friend could sell his old car compared to other prices in the market. So to do that, to solve that particular problem, if you actually have a software that has, in Nigeria, we have a couple of car dealer companies, and then we have some platforms like GG Car 45s, Auto is it Auto Check. We have a lot of cars, buy some. There are a lot of cars like that where they sell both UK used and Nigerian used cars, and new cars, brand new cars as well. But for somebody that wants to maybe buy a car or sell a car, for instance, and it does not know the price point, probably I have a Mercedes Benz, the model, the year, and I want to sell the car, and I want it to. I don't want to undersell my car, and I don't want to oversell my car so that people can actually buy the car. Okay. So if I have an application that can help me predict how much I can sell my car, that would be a great tool, because it wouldn't make me have delay in getting a buyer, because it's giving me the range of prices that buyers are willing to, people that want to buy the car are willing to buy the car. I won't undersell my car, even if somebody is trying. Sometimes people try to take advantage of people when they want to sell something and maybe they are in need of money. They try to like underprice their item. Right. So if it's somebody that actually knows that, okay, at the market value for this car is so price, and not based on speculations, not based on, because a lot of time people say, oh, the market value of this particular car is it's so amount of, okay, there was a time I had the Toyota Corolla 2007, and then I wanted to I wanted to sell it. And then at that time, that was last year, at that time, the market value was actually around 4 million naira. And then the people that wanted to buy the car, they were saying, oh, this car is 2 point something. Super. But then it was afterwards that I got to know that, oh, actually the market value is up around 4 to 5 million, because at that time there was, they had already shut the border, and importation of car prices had already increased. Cars were now very expensive, and people had to start, selling at a higher price. And at that time, that particular car was the kind of cars that people that were doing boats were using. So the car was actually in high demand at that time. But at that time, I didn't really know the market value. I didn't know I didn't really know what was the actual market price. And then the seller, the people that wanted to buy it were just giving that. So if I had an application that could tell me that, okay, I could scan what the prices of cars are. And when you're building machine learning model, you could build it, a software solution that would address the kind of problem. You could have a way to ingest your data at real time. Maybe as you're scraping, you have a funnel whereby you're gathering real-time data, and then you're connecting it to your ML model, and is giving you the accurate prediction of what is applicable at that point in time. So let's get back to what we are doing. Okay. So if I have to if I have to build an ML model based on this problem, all right, the first thing to do is to get the data set. So, and that's what we're about to do. So we're at Kaggle, want to quickly get the data. So we have a lot to do. Let me quickly, I'm just taking you through this route so that you understand how to go about your projects if you want to approach one. Okay, so get the data set. So if you're download from Kaggle, you just click on download dataset. Usually dataset comes with data dictionaries, like description of the data. So you can see sample of the data. You have the model, you have the year, you have the price, you have transmission, okay, you have that's the type of gearbox, you have some other, let me just move it down, the mileage, the fuel type, the tax, road tax, the road taxes paid, you have the miles per gallon, you have sizes in liters. Okay, so all right, so I have this, I've downloaded it, assuming I've downloaded and I have it stored on my local folder. So I just go to that particular folder. I think, let me just see if I have a folder on the, let me see if I have it somewhere here. Local hosts. Let me open my local host tree. Okay, so the folder should be around here. Okay, this is the this is the project folder. All right, so this is the file. It came up in carprices.zip. So I'll zip the file, and then I have this folder where I have the car prices. Okay, so inside that folder, this is the folder rather. So in that folder, when I downloaded, I saw that the CSV, I mean, the cars based on manufacturers, they came on in separate CSV formats. We have the Audi, the BMW, CC Class, Focus, Ford, Hyundai, and so many other car model brands. Okay, so I created a new notebook in here, clicking new and Python tree. So this is the notebook I created. And then after creating the notebook, I did my normal, adding the description of the data set, the data source. Then I want to start my analysis. So you start with your imports, you do your basic importations, and then you do, I saw that we have about, sorry, we have about 1, 2, 3, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 brands of cars. So because I wanted to I don't want to work with a very large data set. I'm working on my local system, but I was using the cloud, right? I could have, tried that. I wanted to use just a little, and then this is just a demo. So I just want to use, I'm going to just pick 5 of the models, maybe the most popular model that people would likely buy. So I picked an Audi, BMW, a Ford, a Mercedes-Benz, and Toyota. So I used those are the data sets I'm going to be working with. So for each of the data sets, I read in each of them and created a variable for each of them. Audi, I read the data sets, and after reading all of the data sets, now what we learned during our Python, so for the Python for data science, if you don't, I mean, if you should have passed through that class before coming to the ML class, except people that have backgrounds in Python before. So for people that attended the Python for data science track, you notice that there was a time we're working on different tables and we have to concatenate the tables together. So usually in real life, you don't have all your data sets in one particular CSV file or Excel file. You have to gather your data from different sources, and then you have to perform merging and concatenations on your data set. So that's why all of those knowledge are very key to what you're doing here, to building your ML models. All right, so these 5 brands. That's what I want to focus on for this model. Okay, so I'm going to come, read in. I want to see the sample of the data set, read in the head, check the head of the data. Now I can see that we have the model here, price, transmission mileage, fuel type, tax, MPG, and engine size, which had been said earlier under the data description. So when I checked that of Audi too, I mean BMW, the same thing. Okay, so the next thing I did was to check the sizes. I want to check how distributed are my data set, I mean the brands, because I don't want a situation whereby I'll have more of Toyota and then I have less of Audi. And when I'm building my model, of course the model it shouldn't be biased towards one brand or the other. So I want to have like a balanced class. So here you see that when I checked using the dot shape function method to check for each of these sizes, and you see that for the Audi we have 10,000, 10,000, 17, 13, which are fairly okay. This, except for the Toyota, we have fewer Toyotas in this data set, which is still okay. Okay, so the next thing that I did was because if I have to merge all of them into a single table, but before I merge them, I have to create another column that would hold the name, because if I just merge them, I might not know which record belongs to which of the manufacturer, right? So if I just merge everything together into a single file, I'm not sure of which of this record belongs to a manufacturer. So I had to create another column called manufacturer, so that I can have the name of the manufacturer associated with each of the car records. Okay, all right, so to do that, I created a new column called, for each of them, Audi manufacturer, BMW manufacturer, and I stored every value in that column should be the name of the manufacturer's name. So it's going to be looking like this. When I load this, let me just load this. So when I load this is how it's going to look like. For example, if you have your Audi, let's add. So you can see that we have a new column called manufacturer, and everything there is everything on that row is called Audi. So that was done because by then I'm merging all the tables together on top of each other. I'm stacking them on top of each other. I'm doing a row concatenation, right? So sorry, I'm doing a column wise concatenation. I'm merging them on top of each other by the column. So I'm going to have to indicate their names so we don't mix up the data sets. All right, so if you check for Audi, okay, let me just do let me do for Toyota too as well. So if I do Toyota, let's add Toyota, sorry. So you see that Toyota now has a new column name called manufacturer. Was not on the original table, so I just included that on this table. Now, another thing to do is to check for duplicate, because you have to first of all perform your data authenticity. You want to be sure that you don't check your data quality. Do you have duplicate values in your data set? Because if you, for example, you could have 1 million data set, and what if about 99% of them are duplicate? That means that by the time you drop all duplicates, you just like maybe 2 rows you have in your data sets, and that is useless to you. So you don't want to work or build a model on duplicate values. So you have to check if they are duplicate. So when I checked for Audi, I noticed that we had in Audi's data set, we had about 103 rows that had duplicate value. More than that, those were the ones that were remaining apart from the duplicate values. So you have for the original Audi, you could see that the original Audi had the shape of 10668. Now, out of that 10668, we had about 103 rows that had duplicates. So we have to remove them. We don't want to have duplicates. It's still okay because we still have a very large data set. Okay, so I want to assume that other ones to have duplicates. So in order, I just wanted if okay, let's check for the other ones. Let's check for another one. For let's check for which of them now? Toyota. So for Toyota, you can see that we have, oh, it's not even giving me the number, but it's a lot. Let me check the number. Okay, it's not giving me. Let me check the length. We have 39 of them that are duplicate values. So you can see that we have a lot of duplicate value in our data set. So what I did was to, first of all, concatenate everything together first. So to do the concatenation, you'll have to use your concat function. Okay, sorry, let me navigate back to my, okay. So you have to do df.pd.concat. So I created another variable that is a new, since this is a concatenated data set, like a bigger data set. So I'm going to concatenate all the BMW, Ford, Mercedes, and Toyota. And then you can see that the shape has increased. That is now the addition of all those five tables. So we have 10,000. If you calculate the addition of all of this, will give you the 59,000 plus table. So you now have 59,271 records. New data set. So we now have a new data set called DF cars. Okay, so if you check the head, you see that you have the cars, a new table with the merge of all the car models. Okay, but then there was a problem because they were stacked up on top of each other. So the first 110,000 rows will be Audi, the next 10,000 rows will be BMW, the next 10,000 will be Ford, the next 10,000 will be maybe Mercedes, and then the next 6,000 rows thereabouts would be Toyota. I don't want those records to be arranged like that. I have to shuffle them because when you're doing your training of your data set, you don't want it's when most especially when you're splitting your data set, you don't want to cut build your model on a percentage of maybe on just Audi and Toyota, and then you're now you're testing your data set on Ford, Mercedes, and BMW. Okay, so you want to have a balanced mix of all your data. All right, so you see that I have to shuffle them. I have to shuffle them together. But before I shuffle them, it's good to always create a copy of your data set. So here I'm going to do df.cars.copy to, I'm going to create a new variable called df new. That is a new data frame. And then I want to shuffle. So let me just keep reloading because I've been loading other pages. So let me just reload this. So here you see that I've now shuffled. But now just beyond shuffling now, I want to split. I also want to check for duplicate values, okay? I've not shuffled yet. Let me first of all deal with all those duplicate values because I need to get them out of the data set. So that's part of my data cleaning process. I'm going to do df.duplicated. So you see that on the entire data set, we have about 672 rows that are duplicates. That's still okay. It's not all of our data set out of 57. Let me check. Is it 57,000 plus? 59,271. We have about 672 rows that are duplicates. So I'm going to remove the duplicates. I don't want the duplicates. Now, if you can see this Q3, Q2, the duplicate value, because I wrote keep, okay, if you have, there is another variable called keep. If you check your duplicated function, sorry, it should be inside the duplicated function. keep equals. Let me just check it so you all can see. So there's an argument called keep. So you can either keep the first item, or you want to keep the last record, or you want to make your keep to be false. When you say keep to be false, when you set keep to be false, it's going to give you the result of all the duplicate values. Whether, sometimes you could have one duplicate, you could have two, you could have three of the same type of record, right? So here, if you set keep to false, it's going to give you every of the values, not retaining anyone. So here, by default, is keeping the first occurrence of the date of the record, and then is returning the remaining ones that are duplicate. Now, if I want to see everything without just the filter, so I'm just going to set skill keep to false, and when I do that, you can see now that the total rows plus duplicates is 1,165 rows. But if we are going to just set our keep to default, that is, we want to just keep the first occurrence, okay, and then the remaining one, the duplicate one, should be returned to us. This is it. So we're going to delete all of this. So how do we drop it? We use the drop duplicates function. All right, so I'm going to create a new copy of my data frame again. I would always want to create a copy so that I don't run into, maybe when I have errors, I can always fall back on the copy. So I'm going to create a copy of this one that we duplicate, okay? So I'm going to drop the duplicates using my def.drop duplicates in place equals true. So when I do this, okay, when I do this, it has dropped the duplicate. So if I check the new duplicate values, I can see that I don't have duplicate values in my data set anymore. It is empty. So if I check the new shape, my new shape is 58,599, which is still fair enough to deal with. And then I check the count of each of the manufacturer. When we're doing our data import, we had the count of each of them, right? Of the manufacturers, that is the data set from each of the manufacturers. So here we had that. We had Audi as 10,000, BMW 10,000 plus, Ford 17,000 plus, Mercedes-Benz, and all of that. So let's check the count after removing the duplicates. We have this. Shall we? Okay, we have this, the Ford, the Mercedes-Benz. So it's still it's still a good count. Okay, so we can still work with this. So now the next thing for us to do is let's just get into our data exploration. Okay, before the data exploration, I want us to check the information of our data set. You can decide to check it now or later, but let's just check. Let's just do a data.info to know if there are missing values in our data set. Why am I always using the comma? Okay, so when you do a df.info, you can see that you have what? It's very clean. They're all non-null. So you see that the total number of entries is it's 58,599, and they are all 58,599 non-null. So we don't have any issue with missing values. So we are good. So now let's move to the next thing. The next thing is to shuffle. I want to shuffle this. When we printed the head, you can see that everything Aldi is first according to, the way we arrange them when we're concatenating. That's the way the records are arranged. So if you're going to open that record in an Excel sheet, you see that you have your Aldi on top first, all the Aldis, then after the 10th, maybe the 10,565 records, you have the next manufacturer's info. So I want to shuffle them, and shuffle them, you can use your dot sample, right? You can use df.sample, and then you give it the length of the data set. That is, you want it to all the data set, the total number of the data set. You want to get a sample of it. So when you use your dot sample, you're shuffling it. So I'm going to save that sample inside a new data set called df. When I do that, I have a new data frame. And now if I load it, you can see that your data frame is now, it's not Audi anymore. You have BMW, Ford, Audi. You should say we have a good mix of all the records together. All right, so that is settled. Now, the next thing, I want to drop this index. This index is giving me, an inconsistent numbering. So I want to reset. When you reset the index, this is what happens. This index becomes a new column, and then you can now drop this index. So it becomes a new column, and then it gives your okay. Let me just do that. You see, let me just put this off and show you what I'm talking about. So when you do your reset index, this is what happens. So let me print out the data set. df.ed. You can see that the index becomes one of the columns. So now we have to drop the index. We don't want the index to be included in it's not part of our column. So we can just say df.drop index, set axis equals 1 because we are dropping across the columns, and then set in place equals true because we want to make it permanent. We want to make it's a permanent change. All right. So when we do our dot drop, you see that the index is dropped, and then you have your new data set in 0 to 1 in a good order. Okay, so let's leave this. Another thing is I want to check the year, the count of the year. I wanted to see the range of cars that we are dealing with. I wanted to know which of the cars, like we have more cars in 2019, then we have the next highest cars 2017, model 16, and all of that down to. So we have a car in 1970. Okay. Could it be an error? Or maybe there was really a car in 1970 that is used. I don't know. So if you want to find out, let's investigate that car that is 1970. Let me check. Let me just remove this and then see. Let's see what kind of car is it. No, let me do this. Okay, so it's a Mercedes Benz. It's automatic. I mean, somebody that knows about cars. Do we have automatics in as far back as 1970? And then the as the Mercedes Benz started making cars far back as 1970. Someone should please help me answer that question. Okay. So let me just even use the data set as it is. Let's assume there was a car in 1970. Let's assume there was a car at 1970. Okay, let's just continue, and let's use the data set as it is. So we have, let's just continue with that. Okay, so I've checked the age. There are no null values. Let's start doing some data exploration. I want to do exploration data analysis. So keep in mind, we are trying to build an app to predict the price of cars. Okay, so we'll want to check the relationship between the different features with our price. So we have the price, the describe function. You see that we have the year, the price, and mileage, the tax, the mileage, the MPG, the engine size, and all of that. So we have that. Okay. For so here you can see that the maximum amount of prices they sold the cars there was 159,999 pounds. It's a UK car, and then the minimum price they sold the car was 495. So the price is really, really skewed to the right because we have more of 50% of the cars, right? Average price is 16,498. The 75% percentile is 23,480. So could this be I mean this price, this price, could it be an outlier? Let's check. So I'm going to check, I'm going to get out that record where the price equals this 1599. Okay, So we have this. Let me get out the record. Okay, equals to. So this is 2020. So it's possible. If the car was like to be a 20, if the car was like to be a 1997 car, I would have said, no, no, why would they sell 1997 car for that price? So it's possible we could have, and this is even a Mercedes G-Class model. So it's possible the car could be that amount. Maybe it's not an outlier. Let me check the cars that are greater than or equals to 100K. So I want to see if we have more cars like that. So that's to check. I want to be sure that it's not an outlier. Maybe it's just one of those cars that are out of range. So, all right. So we have more cars that are greater than 100,000 pounds. So we have a lot of them. Oh, great. So most of them are Mercedes and Audis. Okay. And they are within the 2018, 2020 model. So obviously it might not be an outlier. Maybe it's just very expensive. They're just very expensive cars. All right. So that has cleared our doubts a bit about the price of the car. Okay. And the one that is the one that is 495, let's even check. Is it an outlier? It's possible for them to sell the 495 vehicle could be a very old. Okay, this is 2003. And then it's even a Ford. Okay, it's possible for it to be and the mileage. What's the mileage? Oh, it's a used car, really. So it's possible for them to sell it 495. Maybe because they just want to do a giveaway or something. Okay, so let's go into some analysis. I did a dist plot, check the distribution. So you can see that this is really, really right skewed. And then we have more cheaper cars than the 1,000, but we've seen that all of these cars are not actually outliers. Probably they are just we have more of these cars, cheaper cars the than the expensive ones. So another thing we're going to do is I want to, instead of, because in my model, I don't want to use year to build my model. I'll rather use age of the car. I want to use the age of the car because that would give more insight. Using the year the disparity in my model, it might not really make a lot of good judgment. So I'm going to use age. And how do I use the age? I have to calculate the age of the car. How do you calculate the age of the car? If the car was made in 2020, for example, and we are in 2024, so what's the age of the car? You have to subtract the current year minus the car. I mean, when the car was made, when the car was manufactured. Okay, so that's what we have in our formula. So to get the current year, how do you get the current year? You can use a function called the today function. So you're going to import dates. You can import dates in Python. To get the current date, you can say date.today is going to give you today's dates now. So you can even experiment that. Okay, let's do that quickly. I don't know if I've been loading each of the cells. Let me see. I've not been loading them. So let me just load this place further so as to have. Okay, so okay. All right, so I'm on this place. So here I could let me just break this so that I can show you what the current date is. So let me print our current dates. So you can see that it's telling us today is what, 19th of July 2024. So it's correct, right? Okay, so that is today according to my if I'm sharing my desktop, you see that is actually today's date. Okay, so to get the year, you can use your dot year to get your date. So you're going to just do current date dot year and then store the year. So we're going to use this current year minus the year across each of the columns, across each of all the columns, I mean, all the rows in the year column. So you're going to say current year minus df.year and then store it inside a new column called age. So that's what we are going to do. And then that gives us, you can see that 2019 till date is what, 5 years. Let's look at another one. 2016 till date is what? 2024 minus 2016 is what? 8 years. So we have this age column computed for. So you see that in the process of you building your ML models, you're doing a lot of data manipulation. It's not just all the columns you collected that you're using. You have to do all of these manipulations just to accommodate the machine learning model that you want to build. Okay, so having done that, let's do some let's do some insight. Let's try to get some insights on our data. So we're going to build, let's just compare some of let's do some scatter plots with our price because we want to see those ones because it's a linear regression problem, right? We want to see the kind of data sets that would work. I mean, the kind of features that are actually affecting our price predictions. So here we can see that we can use the mileage because those are the numerical columns. You can use the mileage, you can use the MPG, the engine size, and then you can use the tax as well. I compare it with your price just to see if there are any relationship. So let me do some the price and mileage and tax. So let's do this is the first one with we are doing it with the engine size. Okay, so you're going to see a plot. You're seeing that the engine size is showing us the correlation. It's not, there's no much correlation between the engine size and the with these plots, but let's try to check let's check mileage. Maybe mileage can give us some insights. Okay, mileage, mile and age. Okay, mileage, age. So let me change this as well to mileage. Mileage. Okay, so we have this as well. So you can see that we have a correlation. The correlation is like this. It's going to we have more the cars with a lower mileage, right? I mean, we have, if we want to interpret this gap, so like this car with 0 mileage is super expensive. You can see it, right? The cars with 0 mileage is super, super like the ones and that's obvious. So mileage is a very strong predictor because it's obviously showing us that the cars with 0 mileage or lesser, I mean, those ones that with lesser mileage are very expensive. Are the ones that are, new cars, brand new cars that people have rarely used. Okay, so that could show us an indicator. Let's check the MPG as well and see tax too. Let's see the relationship. We'll do the same thing for MPG and tax. MPG, MPG, MPG. Reduce it. So 6.4. Okay. Also, the MPG2, the kind of correlation is showing us is that those ones with lower MPGs are super expensive compared to the ones with higher MPG. Right? You see, the ones with higher MPG, like this one that has very high MPG is cheap. Okay. All right. So let's also check the tax too. Let's check the relationship with the tax. Okay. The relationship is not even looking very, it's very, it's not straight. It's showing you a very scattered relationship. But then you can see that those ones with tax of around between 0 to 200 to 300, they have like higher prices. Okay, there's another one with the tax is not very correlated. You can't really see so much relationship with them. But you can use other plots. If you use other plots, it can give you more insight. So let's move further. Let's do a manufacturer. Let's do categorical plots with the price. Let's do manufacturers against the price using a bar plot. So when you do manufacturer against price, you can see that the most expensive cars are Merc, BMW, and Audi, which is expected. Mercedes-Benz is very expensive, followed by BMW. BMW and Audi are around the same age. Toyota and Ford. Really? Ford is that cheap? They're around the same age. Then you can also use you can set the EU of transmission. You want to see those ones that though here you can see it strictly, but then you want to add some layer of insight to it. You want to see if the transmission would affect the prices. Okay, so you can see that out of the cars that are very expensive in Audi, the ones with semi-automatic and automatic are most expensive. The ones with manual and other are not expensive. They are just they are okay. But if you see Mercedes-Benz as well, you see that the ones that are really expensive are the ones that are semi-automatic in Mercedes-Benz, which is very unusual. You could have said that, oh, automatic would have been very expensive. But see, semi-automatic here, even in BMW, now you can see that in BMW, though was very small, you see, if when you look at BMW here, but then there is a semi-automatic in BMW that is even more expensive than the most expensive car in Mercedes-Benz. So you can see what this layer of insight is doing to you. It's giving us more insight regarding our data and regarding the brand, the manufacturer, how it relates to the price. So all of these are pointing towards something that this could be, transmission could be also a very good predictor for our data set. Okay. So you can go on and on. Like now, you see here now, fuel type. Now, I want to see whether electric cars or the type of the fuel type. I want to see if it's going to be, affect the price, the counts. How many out of the Audi? How many electric cars do you have on the graph? It's not even showing. But we see that most of the cars here are petrol cars, gas cars. The ones that are and then you have diesel cars as well. You can see Audi diesel, Mercedes-Benz. So you can go on and on to do so many explorations, but because of our time, you can go on and on to even check add the diesel, the fuel type. You can add it to this hue to see, okay, instead of transmission, let's check the fuel type and the manufacturer. What's the relationship? You see all of the insights as well. Okay. All right. So because I want us to cover how to use our model after development, so I'm going to go ahead to continue with what. So, but here, see the hue here, there's a way to manipulate this. You can set this as an axis, AX, and then you'd define you can adjust this legend using this. You can use SNS.move legend. You can move it anywhere, maybe upper left, and set the height where you want to, location where you want to move it to. So let me just copy this because of time. Just going to copy this and then let's go ahead to, let me load other graphs that I've not been loading. This one is it too. Okay, let me load this. This is going to throw an error because I've said I didn't print it. So I'm going to do this ax move legend. Oh, it has done that for me. Okay, no, it's this. I'm gonna move the legend now. Okay, so when I move the legend, you see that it's now outside the graph. All right. Okay, so moving forward, you can see that we have done some data explorations, right? You've done some little explorations. Now let's start doing correlation. Let's start, gradually building our model. So when you do your correlation matrix, with the price, you can see the highest correlated item is the engine size, followed by the tax. The year might not really give you the right correlation. That's why if you see when you convert the year to age, see that the age is now giving you a negative correlation because this year is very, very large. So it might not really give you the exact figure, all right, because the values are very, very wide from the price. So you could also see here that you see the price with itself, of course, will be one. The mileage was giving us a negative. The tax is giving us something positive. We have the engine side. So, but let's just, continue. So you can also apply your feature selection algorithm on your model to improve the performance if after building your baseline model and then your results is poor. Okay, so when we do our correlation map, it gives us the correlation matrix. And then you can also do the box plot. If you do box plot of the transmission against the price. Now you can see that there is a lot of outlier. Under the automatic, you see more of the values are squeezed between 0 and 40, maybe like 50,000. So the prices of automatic cars, you have a lot of outliers outside the range. That is, it has shown on our price distribution that they are the price is actually right skew. That is, they are compressed towards the origin, which this graph is showing us. Okay. So because we don't want to completely eliminate those prices, they are possibly original good prices because we checked them, which they are not far from the truth. If it's something like 1 million pounds, that could have called for, and then it maybe the manufacturer's date is an old model. You just be thinking that, oh, maybe that was a mistake. Okay, so moving forward, let's just continue. All right. So we did a value count of the model, the car model. It's a lot. We have a 118 model because of our machine learning. We have to convert all of these categories into numbers because it won't use a machine learning model would not use strings. So but then we have about 115 models. So in order to just we want to eliminate some highly correlated, like model and manufacturer is kind of similar, right? The manufacturer can tell us the kind of model, so it's better to use the one with a lesser category for our modeling. So I'm going to just choose to use the manufacturer instead because the model has 115 distinct models, and of which we have the manufacturer giving us that information already. So let us leave out the model from our analysis. So we're going to leave out the year as well because the age is there. We are going to use the price transmission. We're going to convert it to numbers because transmission is a good indicator. We saw it in our graph. Then we have the mileage, the field type. So it's the categories are limited. We're going to use that. We convert it to numbers, and then the manufacturer will also convert them to numbers. Okay, so to do that, we're going to use our one-hot encoding because these are not ranked columns. It's not a ranked automatic manual is a ranked column. Diesel hybrid, they're not ranked. Audi, Toyota, they're not ranked. So we're going to just use our one-hot encoding. So when we use our one-hot encoding, we can use a pd.get dummies, and then you see and concatenate the dummies with the original data set. So when we do that, you see that we have a bigger data frame. You see diesel, electric cars, hybrid. I explained what that meant in previous, classes, what one-hot encoding mean and all of that. So you see that this is just putting together what we've learned over previous classes. All right, so having done that, now it's time to build our model. And for let's just use a linear model and build a baseline model. So that would give us quick insights as to, okay, what is our the best model that we can get, even without doing so many manipulations. So first of all, I'm going to drop all those ones that we don't need, like the model, the year, the transmission, that because transmission has been one not encoded, we're going to drop it. Field type as one not encoded, we're going to drop it, and manufacturer as one not encoded, we're going to drop. The price is not part of our feature because it's going to be our predictor, so I'm going to drop it as well. So when you do that, so let me just load this, all of this, so that we can continue from there. All right, so when you do that, this is what you're going to have. Now you see that all those other ones have been dropped. Now you have all of these columns for your model, for building your model. Now we have our X and our Y. Okay. So let us use let's build a linear regression model. So from sklearn.model selection, import train test splits. From sklearn.metrics, import mean squared error. That's the evaluation metric one. You want to use the root mean squared error. So you're going to do your splitting, X train, X test, Y train, Y test, and we're going to use a test size of 20%. Random state 42. So I can increase the test size. Let's do 25%. So that's so we have a linear regression model, linear regression, and then we fit it with our X train. All right. Then we can evaluate it. First of all, we have to make predictions. This is our intercepts, okay? And then we're going to make predictions with our lm.predicts, and then we want to check our error. Now you see that the error is about our score is 74%. That is just fair enough. We have 74% accuracy. Our root mean squared is 5554. Our mean squared error is a large one, and then mean absolute error is 3405. So this can be improved. I mean, we've not used, this is just the basic model. We've not even used other models. We've not done our feature selection. We've not done anything, and then we have 74% accuracy. So it's a very good place to start. So if we just want to implement maybe some more models, another thing is to do feature selection on your model. All right. So because of our time, I want us to cover how to how to use this model in production. Assuming we have this model is a very good model, right? It's a very good model. And then we've done all our feature selections and everything. We've improved it. And then we want to use it to build an interface for other people to work with, to use. Okay. How do we go about it? One, you have to save the model as a pickle. So you have to import pickle. So I'm doing this because of our time. It's going to take us like next 30 to 35 minutes. So let me just do this. And if there are more times, we'll come back to improve the performance of our model. If we have more time, and I want to take questions as well. Okay, so moving forward, let us build our model. Let's build an interface to our model. So you import pickle. Pickle is like is a way you can save your model in Python so that you can reuse it in you can integrate it with other applications, you can integrate a front-end application, a mobile app, or any place that you want to use this model. Okay, so we have the import pickle, and then you save the model, the name, you give it a name. We can give our model linear model.sav. Okay, giving it a file name. Afterwards, you're going to use pickle.dump. You remember the name of our model is LM that was built. This is the model that we fitted called LM, right? So you're going to use that name as that is the model you're saving now, comma, open the file name, comma, then this is just like a file naming, a write back. You're naming it the file authorization with associated with this particular file. So you're just you're just giving it, you're making it a write kind of file, like you can write into this file. So this LM is the model, and then you're writing it into this file. So this model is saved. So when you want to load the model, so for example, you want to reuse the model, you can load the model into this. Let me load it now so that you see an example of what I'm saying. So this model has been saved before, so I'm not going to run this again. It's been saved already, so I don't want to run it. So I'm going to use this. I'm going to load this model. Okay. Load underscore model, pickle.load, open, then you use this, then you convert it to pickle, lm dot to, oh, no, okay, this is not here. This is not included. This is how you load the model. So if I want to load this model, I can just use load model, and then I can use the model to predict future load model. And then I can now use the model to predict future. For example, I want to dot predict. I can use predict future output. Load model dot predict. Then I can start inputting my all the these are the coefficient. I'll put the mileage, the tax, MPG, engine size, age, automatic, manual, blah blah, alt semot, and all of that. I'm going to input all of this information for my model. I'm going to input everything for the model, and then I'll get the response, whether I'll get the price. So let me just, this is a lot. We have the mileage, the tax, MPG. So assuming, let me just look for one of the test sets. I'm going to use one of the test sets. Let's look for one of the test sets, because I can't start extracting that now, writing that. So let me just look for one of the test sets. This is the X train, Y train. Okay, this is X test. X test dot sample. So this is one of the test sets, right? So I'm going to just do to array. To array. Supposed to convert it to an array. Okay, let me just use this sample. Let me just give it this. Okay. Oh, I can just use this as. So I can just say predict tests. So you can see that it has predicted that it is the price is going to be 13,698 naira. So I can round it up. I can just round it up to 2 decimal place. Round to a 2 decimal place. So let me just select the array. You can see that this has been rounded up to a 2 decimal place. So you can see the price of that car, of this test set. You can see the price. All right. So that's how to reuse the model. Okay. So let me just, to build an interface, there's an application called Streamlits, which we introduced to the Python for data science class when we're doing the